the distance from there to here was 23 feet and 2 inches.
Okay, so in case you didn't understand what just happened, I was trying to kick a soccer ball. Sadly, once I kicked the ball, my shoe went flying off into the distance instead of the ball itself. Today, we are going to figure out how high my shoe went, the dy, how fast it was initially going, vi, and its horizontal and vertical speeds. Horizontal and vertical speeds. Our first step for solving these variables would be to identify the knowns and unknowns. The knowns are what we already know. For example, here we know the total x displacement, and we know the angle at which the shoe was kicked in. The knowns here are split up into two directions, the x direction and the y direction. The x direction has the horizontal velocity, the horizontal acceleration, which is 0 meters per second squared, the horizontal distance, which has been stated earlier here, and the time, which is not horizontal or vertical. The vertical direction, however, has the vertical velocity. It has the vertical acceleration, which can be either 9.8 meters per second squared or negative 9.8 meters per second squared, depending on whether the object is rising or falling. And the time, yet again, is 0.76 seconds. The unknowns, however, are the final horizontal velocity, the initial velocity, the vertical distance, or the vertical displacement, if you will, and the final vertical velocity. Our first step here in solving for these variables will be to find the vertical velocity, this diagonal value here. And the way you do that would be by using this formula. Distance equals initial velocity times time plus half times acceleration times time squared. Now, as you can see, I first plugged in all of the values here, and I used 9.8 meters per second because the object is going upward first. So after I have done that, I multiplied a half by 9.8 meters per second squared first, and then I squared the time, which was 0.76 seconds. This led on to me multiplying 4.9 by 5.776, which resulted in 2.8024, and I subtracted that from 7.612. I subtracted that from the distance, which equal to 0.76 vi, which equal to 4.23096. And then I divided both of those by 0.76, and that is how I got the initial velocity, which was 5.57 meters per second. Now that we have the initial velocity in the diagonal direction, we can go on to finding the initial velocities in the horizontal and the vertical directions, which we do here. For the horizontal direction, we do Vix equals the initial velocity times cosine 40, because 40 is the degrees right here, and that will get us 4.27 meters per second. Pretty simple. And you do the same exact thing for here, except here you use sine, as you can see there, because it's opposite over hypotenuse of this triangle, which equals to 3.58 meters per second. Last but not least, the last and slightly more tedious thing to find is dy, or the peak height of how far, or how high, I should say, the shoe has ever gone so far. And in order to find that, you need this formula. The final velocity, the final vertical velocity squared equals the initial velocity squared plus 2 times the vertical acceleration, which also times the peak height. Now, in order to do this, you have to first make Vfy squared 0. This is because once the shoe falls, which which will equal the final velocity, the shoe doesn't move. And since velocity means speed, then the shoe technically has no speed, which is why it is going at 0 meters per second squared, which is why I plugged in 0 here. And for the rest, I just plugged in the VIY, which was over here, and I put in a negative 9.8 this time for the vertical acceleration, or the gravity. This is because over here, as you can see, the object starts to descend towards its halfway point, which is the basic gravitational pull of the Earth. That is why it's going in a negative direction and not a positive direction. And the dy is the variable which we're trying to solve for, so obviously there's no values to plug in just yet for that. The next step would be to obviously square 3.58, which would get you 12.82. And you subtract that by whatever net 9.8 times 2 is, which is in this case negative 19.6. And then you subtract 12.82 by 0. That would equal a negative 9.6 times dy, which would equal negative 12.82. Divide both sides by negative 9.6, and then you get your answer, which is 0.65 meters, which is the peak height. Now we can plug in the values into the diagram. Alright, so here is what the finished product should look like. Here's what the entire diagram with all the answers should look like. So, in conclusion, my shoe, which fell off while I was trying to kick the soccer ball, flew up 0.65 meters, and then came down, of course, and it was initially going 5.57 meters per second, and I kicked it up at a 40-degree angle. The initial vertical velocity was 5.58 meters per second squared. I mean, just meters per second, sorry. And the horizontal velocity was 4.27 meters per second. So, hope this helps.